This video is about identifying the converse of a statement, identifying the inverse of a statement, identifying the contrapositive of a statement, and creating a biconditional statement. So, as we recall from yesterday, a conditional statement can be written in the form if then or P to Q. By switching the hypothesis and conclusion, we get another type of statement called the converse. So now we're going to go Q to P. While the conditional statement might be true, the converse can be true or false depending on the statement. So write this statement as a conditional if not already. Write the converse, then identify if the converse is true or false. Give a counterexample if it's false. So in number one, we already have a conditional statement. If an angle measures 112 degrees, then it is an obtuse angle. So our converse, we're going to switch our hypothesis and our conclusion. They're going to switch spots to make our new converse. So our converse then is going to be if is an obtuse angle, then the angle measure is 112 degrees. This statement, of course, is false because remember that an obtuse angle can be anything between 90 and 180. So we're going to say false and then give some other kind of angle measurement. So let's say 97 degrees, or we could say 171 degrees. Number two, if 3 points are collinear, then they lie on the same line. So our converse here, we're going to switch again the hypothesis and the conclusion. So our converse is now if 3 points lie on the same line, then they are collinear. When you're writing your converse, remember it doesn't have to be word for word switched, but the main ideas need to be switched in the order. So this statement, if 3 points lie on the same line, then they are collinear. This is a true statement because that's a definition of collinear. Number three, a Dalmatian is a dog. So in this case, we don't have our conditional, so we need to write that first. So we first need to make an if-then statement. So our conditional here could be if it is a Dalmatian, then it is a dog. So our converse, then we're going to again switch the order of our hypothesis and conclusion. So our converse will be if it is a dog, then it is a Dalmatian. This statement is false because remember there's different types of breeds of dogs. So just because it's a dog doesn't mean everybody's walking around with a Dalmatian. So we could say false and we could say that it is a lab or a pit bull. Four, a rectangle is a square. So our conditional statement would be if it's a square, then it's a rectangle. Our converse then is going to switch the order. So now we're going to say if it's a rectangle, then it's a square. This statement is also false because rectangles don't always have to be squares. So if I draw a picture and I say my sides are 3 and 5, this would be a rectangle because opposite sides have the same length, but it would not be a square because all four sides aren't the same. Remember that we can write a conditional statement in the form P to Q. We can write a converse then in the statement of Q to P. We have two other types of statements. Both of them deal with the negation or making them negative or the opposite. Keep in mind that negation means opposite. It's not a negative statement. So I could say it is not raining. The negation would be it is raining. So it doesn't always have to be a negative statement. So our next type of line then is an inverse. An inverse negates the hypothesis and the conclusion. Like a converse, it can be true or false. It's written in the form not P to not Q. So we're going to write the inverse and then identify if the inverse is true or false and give a counterexample if it's false. So in number 5, if an angle is a vertical angle, then the angles are congruent. So our inverse here, we're going to keep the same order, but we're going to have the opposite. So basically for the opposite, if the word not is already there, we're going to take it out. If it's not there, we're going to put it in. So in this case, we would say if an angle is not a vertical angle, then the angles are not congruent. This statement then, if an angle is not a vertical angle, then the angles are not congruent. This is false because they might not be a vertical angle, but they might be an angle bisector and they might still have congruent angles. So if we had an angle bisector, our angles could still be congruent even though they're not vertical. So this is false. Number 6, if an angle is 90 degrees, then it is a right angle. So our inverse, we're going to take the opposite. If an angle is not 90 degrees, then it is not a right angle. This statement is true because the only way you can be 90 degrees is be a right angle. So if you're not 90 degrees, there's no way you can be a right angle. Number 7, if your pet is not a dog, then it is not a golden retriever. So notice that it already has the word nots. So we're going to take not out in order to make it our inverse. So in this case then, our inverse would be if your pet is a dog, then it is a golden retriever. This statement is also false because just because you have a dog, there's lots of different types you could have. For example, you could have a bulldog. Our last type of statement is a contrapositive. A contrapositive negates the hypothesis and the conclusion and switches the order of them. So it can be written as not Q to not P. So we're going to write the contrapositive, identify if the contrapositive is true or false, and give a counterexample if it's false. So number 8, we have if an angle is a vertical angle, then the angles are congruent. So we have our hypothesis and our conclusion that need to switch order again, and we need to make them the opposite. So our contrapositive here then would be if the angles are not congruent, then the angles are not vertical angles. This is a true statement because in order to have vertical angles, they have to be congruent. So if they're not congruent, then there's no way that they can be vertical angles. Number 9, if an angle is 90 degrees, then it's a right angle. Our contrapositive is going to switch the order and take the opposite. So if it is not a right angle, then it is not 90 degrees. This statement is also true. Our last one, if a pet is not a dog, then it is not a golden retriever. So we're going to switch the order and take the opposite again for the contrapositive. So we would say, if it is a golden retriever, then it is a dog. This is also true because a golden retriever is a type of dog. So now we're going to practice writing the converse, inverse, and contrapositive statement, and then telling whether each is true or false. If it's false, give a counterexample. So let's look at number 12. Our conditional here is if the measure of angle A is 100 degrees, then A is obtuse. So for our converse, remember that converse, we switch the order. So converse goes Q to P. So we're going to switch the order. So if angle A is obtuse, then the measure of angle A is 100 degrees. This statement would be false because we might have an angle that's 99 degrees, because that would still be an obtuse angle. The inverse statement, we're going to leave the same order as our conditional, but we're going to make them opposites now. So we would say not P to not Q. So our inverse in this case is going to be if the measure of angle A does not equal 100 degrees, so we can just cross out the equal sign, then angle A is not obtuse. This statement is also false because it could still be obtuse depending on what angle A actually is equal to. So this is a false because we could still have obtuse angles if it's not 100 degrees. Our last type of statement then is a contrapositive. So remember, we're switching the order and taking the negation. So not Q to not P. So we have if angle A is not obtuse, then the measure of angle A does not equal 100 degrees. This statement's true because if we don't have an obtuse angle, then there's no way that our measure can be equal to 100 degrees. The last type of statement that we have is a biconditional. It can still be written in the form P if and only if Q. This means that both P to Q and Q to P are true. So if a biconditional is true, it has to be true backwards and forward. So, which means we have to have a true converse and a true conditional. So number 13, see we have our biconditional because we see the words if and only if. So an angle is a straight angle if and only if it measures 180 degrees. So our conditional in this case, we're just going to add in if and then, and we're going to drop the if and only if. So we would have if an angle is a straight angle, then its measure is 180 degrees. For our converse, we're going to flip the order. So then we would have if an angle measures 180 degrees, then it is a straight angle. For number 15, we're going to write the converse and the biconditional. So we already have the conditional, which is if 4x plus 7 equals 19, then x is 3. So our converse would be if x equals 3, then 4x plus 7 equals 19. Since this is true, we can write our biconditional and we can say 4x plus 3 equals 19 if and only if. If you want to abbreviate that, you can use IFF, x equals 3.